NASA recently announced that Voyager 1 is once again communicating with Earth. On the surface, it's a triumph of engineering. But beneath that headline lies a reality far more unsettling. The most distant object ever crafted by human hands began transmitting something that defied every law of logic. It wasn't just a loss of signal. It was a descent into mathematical chaos. For months, the data streaming across NASA's monitors was a fractured, disordered mess, gibberish that lacked any recognizable telemetry. To the engineers at JPL, it looked like a death rattle, the final moments of a 50-year-old machine finally succumbing to the cold. But as they began to strip away the layers of cosmic interference, a chilling realization took hold. Voyager hadn't just malfunctioned. It had crossed a threshold into a region of space so volatile it left the world's greatest minds stunned. What if the boundary of our solar system isn't a destination, but a gate? Today, we are decoding a message sent from 15 billion miles away. We're going to dissect the glitch that nearly killed the mission, the impossible long-distance surgery required to fix it, and the terrifyingly beautiful sights this tin can has witnessed in the absolute dark. 2. The 15 billion mile surgery. To grasp why this recent data is so jarring, you have to understand how close we came to losing our connection to the deep forever. In late 2023, Voyager 1 stopped making sense. Instead of organized packets of information, it began beaming back a stream of ones and zeros that followed no known pattern. It was as if you received a message from a lifelong friend, but instead of words, the screen was filled with thousands of random, unreadable symbols. The initial diagnosis pointed toward a hardware failure, but the truth was more surgical. A single memory sector within the Flight Data Subsystem, FDS, had been corrupted. Imagine a chip no larger than a fingernail, drifting in the void, likely struck by a single high-energy particle of cosmic radiation. Out there, with no magnetic shield or atmosphere for protection, the universe is a shooting gallery. These particles can rip through circuitry and flip a single bit of memory, turning a command into a catastrophe. The instructions Voyager relied on were suddenly scrambled. The probe was still awake, but it was speaking a language that no longer existed. The team at the Jet Propulsion Lab was essentially staring at a ghost. The fix? They had to reprogram the primary data system from 15 billion miles away, an operation never intended to be performed. 3. Technology from a lost era. We have to remember that Voyager is a relic of the 1970s. It operates on less than 70 kilobytes of memory. To put that in perspective, that is less data than the header of a single modern email. There were no cloud backups, no secondary processors, and zero protocols for a remote intervention of this magnitude. The engineers had to manually rewrite every line of code into raw binary, shifting it to new memory locations, and then transmit it in tiny, fragile fragments. Here is the most agonizing part. A signal takes 22 hours to reach the probe, and another 22 hours for the response to crawl back. Every enter key pressed was followed by a 2-day wait. A single typo meant permanent silence. But after weeks of agonizing patience, a signal finally cut through the void. It was clean. It was structured. Against all odds, Voyager 1 had reinitialized. It performed a system-level recovery that it was never designed to survive. It was a miracle of 20th century hardware meeting 21st century desperation. 4. A mission borrowed from time. The fact that Voyager is even functional enough to glitch is a testament to a mission that was never supposed to last this long. Launched in 1977, the twins, Voyager 1 and 2, were built for a 5-year tour. They were constructed with less computing power than the cheapest pocket calculator you can buy today. Their survival depended on a once-in-a-lifetime alignment of planets, a cosmic bridge that appears only once every 176 years. This allowed the probes to use gravitational slingshots, stealing momentum from one gas giant to hurl themselves toward the next. NASA knew this was a narrow window. They acted on a gamble, fully expecting the mission to end shortly after passing Saturn. Because they were heading into the darkness away from the sun, solar panels were useless. Instead, they carry a nuclear heart, a radioisotope thermoelectric generator. It's a slow-decaying battery that converts heat from plutonium into a steady trickle of electricity. Voyager 2 left first, but Voyager 1 was faster, eventually overtaking its sibling to become our lead scout into the abyss. They were just metal boxes thrown into a graveyard, yet they refused to die. Monsters in the Dark, Jupiter and Saturn. When Voyager 1 arrived at Jupiter in 1979, the images it returned shattered our understanding of the cosmos. It didn't find a peaceful planet, it found a monster. Jupiter was a violent, radioactive world surrounded by magnetic fields so powerful they could fry a spacecraft's nervous system in hours. The probe discovered that Io, a moon we thought was a dead ice ball, was actually a volcanic hellscape, shooting plumes of sulfur hundreds of miles into the vacuum. Then came Saturn. We knew about the rings, but Voyager showed us they were braided, chaotic, and governed by shepherd moons. We saw Titan, a moon wrapped in a thick, orange chemical haze. It looked like an early, frozen version of Earth, a laboratory for the building blocks of life, hidden behind a curtain we couldn't yet see through. 6. Into the Ice, Voyager 2's lonely path. After Saturn, the twins parted ways. While Voyager 1 climbed up, out of the planetary plane, Voyager 2 pressed on toward the ice giants. In 1986, it reached Uranus, finding a world that spins on its side like a fallen top, with a magnetic field that is completely broken compared to any other planet. In 1989, it reached Neptune. Far from being a quiet, frozen sphere, Neptune was home to the fastest winds in the solar system, supersonic storms larger than Earth. It saw geysers of liquid nitrogen erupting from the moon Triton. These images remain the only close-up views humanity has ever had of these worlds. No one has been back since. Everything we know about our outer neighborhood comes from these brief 1980 snapshots. 7. The edge of the world, the Heliosphere. Eventually, the planets were left behind. Voyager 1 kept moving into the nothing. But that nothingness turned out to be the most fascinating part of the journey. The edge of our solar system isn't a line on a map. It's a violent, invisible bubble called the heliosphere. This bubble is created by the solar wind, charged particles screaming off the sun, colliding with the interstellar medium, the dust and gas of the galaxy. Scientists had dozens of models for what this boundary would look like. Most were wrong. In 2012, Voyager 1's sensors began to scream. Plasma density surged. The solar wind vanished. It had broken through. It was the first human object to enter the space between the stars. But when Voyager 2 followed 6 years later, it found something entirely different. It found a leak, a massive flow of particles stretching 150 million kilometers. 2 probes, 1 solar system, yet 2 completely different exits. 8. The wrinkled horizon. The data revealed a terrifying secret. The edge of our solar system is wrinkled. There are giant folds in space, billions of miles wide, where the bubble of our sun is being crushed and pushed by the galaxy's pressure. It isn't a smooth sphere, it's a breathing, distorted shape. In some areas, the edge of the solar system actually chased the probes as they tried to leave. What we thought was a silent crossing was a chaotic, noisy struggle for dominance between our sun and the stars beyond. 9. The Golden Ambassador. But Voyager is more than a sensor. It's a tomb. Bolted to its side is a 12-inch golden record. This wasn't a scientific instrument. It was a desperate act of art. Curated by Carl Sagan, it contains the sounds of our oceans, greetings in dozens of languages, and a map to our home. The odds of an alien civilization finding a small piece of metal in the infinite black are effectively zero. But the record wasn't built for them as much as it was for us. It is a declaration that we existed, that we made music, felt love, and tried to understand the dark. It is a whisper that will endure for millions of years, long after the Earth is consumed by the sun. X. The Final Descent. Right now, Voyager 1 is over 15 billion miles away. The distance is so vast that light itself takes nearly a full day to bridge the gap. They're drifting into a silence that has no end. But the mission is dying. Every year, the nuclear batteries lose power. NASA is currently performing a heartbreaking triage, shutting down heaters and cameras one by one to keep the data flowing. By the 2030s, the power will likely drop too low for even a heartbeat to continue. The antennas will go silent. But even when they go dark, they won't stop. They will coast for eternity, carrying our biology and our history into the depths of the Milky Way. Yet, some engineers are left with a final, haunting thought. The glitches, the corrupted memory, the strange pushback at the edge of the bubble. It almost feels as if the universe noticed us. It feels as if we knocked on a door we weren't supposed to find, and something in the dark reached back to see who was there. What do you think? Was the glitch just a stray particle or a response from the void? Let me know in the comments. If you want to keep exploring the deep with us, subscribe and hit the bell. The universe is full of secrets, and we're just getting started. Thanks for watching. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.